Hi all, we're doing uh, activity 1 in single replacement reaction, stoichiometry, and percent yield. So we're going to use a 50 milliliter graduate cylinder to measure the 1 MCuSO4 in the bottle and place it in the 250 milliliter beaker. Record the total volume in the data. Okay. So we have our 250 milliliter beaker, 50 milliliter graduate cylinder. And it says the bottle of the copper sulfate will contain approximately 100 milliliters of solution. Use the 50 milliliter graduate cylinder to measure 50 of the solution and add it to the beaker. So we could do 50 at a time so that we're getting those measurements. Excuse me. So there's 50. We're going to want to take it two ways. That's in the 50 milliliter. So I want to tar this. Okay, so let's see how much this weighs by itself. That's 37.65. That's just the weight of the cylinder, and then we're going to add 50 milliliters. With the first 50 milliliters, we go up to 92.79 grams. We'll do this again. Perfect. Not sure about that color change there, if you can see that. Okay, either way. So for some reason it may be too heavy to get a reading. Okay. So that's something we may have to look into. So it says add approximately 1/8 teaspoon of table salt, or NaCl. We're going to go ahead and do that. Let's use a weight boat here. Or actually a spoon it calls for. So really it should be about 1 gram. I just used a little salt packet, seemed easier to me. And we're going to stir that around. So it's noting here that the sodium chloride is a catalyst, so that the exact amount is not important. 1 salt packet from a fast food restaurant should be sufficient, so that's exactly what I did. Stir the solution with a plastic spoon till the table salt is dissolved. And then it says cut a 3-inch by 12-inch piece of aluminum foil, weigh it, and record the aluminum foil mass in the data table. So we stirred this up. Let's set these things out of the way. Put those things out of the way. We have I went ahead and pre-cut this. So our 3-inch by 12. See how much this weighs. Let's tar that out. There we go. And that aluminum foil is about 95 grams. So we'll want to record that. 90, 95 grams. Good. And it, so 0.95 grams to be specific. And that information we would run a record and put in the data table. It says for best results, use between 1.4 and 1.6 grams of aluminum foil. So let's actually add a little bit more aluminum foil here so that maybe we can get better results. Okay. Let's take a little bit off. That's 1.1. Need a little more. And that's about 1.5. So that's the recommended amount. It says, I want to make sure this is in the picture here. Tear the aluminum foil into small pieces, approximately 1 inch by 1 inch, and add them to the salt and the copper sulfate. So let's just kind of do that. Let's kind of mix those in. Kind of stirring this as I go. And if you can, I want to bring this really close, you can see that the aluminum foil is starting to bubble. And it's really neat. I want to make sure you can get that. It's a pretty cool reaction going on here. I'm going to put this camera up so you can see. You see there's some reaction, some chemicals, looks like some gas giving off. Look what's happening to that foil. So probably with the production of bubbles, it's warm. This is really neat.